Hello, my name is Mr. Holtzke, and this is Mr. Melsna's Chemistry Unit 2, Lesson 1, which deals primarily with atomic theory, scientists involved in atomic theory, and the structure of the atom. This is the table of contents. I would encourage you to use this in your exploration of the unit, in addition to being sure that you complete Slide 2, Slide 3, and Slide 6, as they all deal with your Chemistry Unit 2 Foundation Worksheet. Please also pay special attention to any vocabulary and critical thinking questions located sporadically throughout the unit, as they will be helpful in understanding some of the complicated concepts that will be discussed later in this unit. Section 1 can be found on pages 312 through 317 in your textbook and deal primarily with scientists and their contributions to atomic theory. I would encourage you to become familiar with the different models located in this section. I would also like you to become familiar with the following terms: electron and nucleus, as they will be discussed more in depth in the following sections. Once again, please become familiar with this slide before continuing to the next. This concludes this slide. This brings us to our Chemistry Unit 2 Foundation Worksheet. I would encourage you to have filled out this worksheet as completely as possible before attending to this slide. Any assistance you may need can be found in your textbook from pages 312 through 317. Please pause now if you have not attended to this worksheet in any way. I will now begin. According to pages 312 through 317, the atomic theory has been around for thousands of years. To develop concepts like the atomic theory, scientists create models. To explain experiments and/or results from their hypothesis, which, as you know, is an educated guess about our world. An example from the chapter would be the plum pudding model of the atom, which you should have already reviewed through your reading. The first scientist we'll discuss is Democritus. This gentleman lived in the late BCs, around 440. His contribution was that he coined the term atom. The next scientist we'll discuss is Aristotle. He was around at about the same time, which would be about 440 BC. His contribution, ironically enough, was incorrect. He proposed that atoms consisted of particles made of earth, wind, and fire. Unfortunately, Aristotle's theory actually set back atomic theory a number of years. The next scientist is Mr. John Dalton. This gentleman was about quite a bit later, in the late 1700s. He actually published the first atomic theory based on experimental data. This is important because prior to that, support for atomic theory was less than preferable. In other words, it wasn't based on experimental data. It was based on assumptions, experiences, observation. This was the first solid theory for what an atom truly consisted of. This concludes this slide. Continuing on, the next scientist we'll discuss is J.J. Thomson. This gentleman lived in the late 19th century, 1897. His contribution was that he discovered the electron. This was a pretty significant find because up until this point, no one really knew what the atom was made of. His research was continued by a gentleman by the name of Rutherford 20 years later, in 1911. He conducted the gold foil experiment and actually discovered the nucleus of the atom. So now we have the electron and the nucleus being discovered. Niels Bohr would be the next scientist. This gentleman lived a few years later than Mr. Rutherford, and he identified paths that electrons traveled on. His atomic model, known as the Bohr model, named after himself, is still used today as a way to explain the different structures of an atom, even though it isn't completely and technically correct. The next two gentlemen we'll discuss are Irwin S. and Warner H. These gentlemen lived in the 20th century and discovered, contrary to Mr. Bohr, that electrons actually traveled in a cloud surrounding the nucleus, and they didn't really travel on defined paths. There is quite a bit of variability in how the electrons traveled around the nucleus. However, since Mr. Bohr's model was still excellent at explaining the structure of the atom, his model was allowed to live on, even though technically the following scientists, Irwin and Warner, were more correct. This brings us to our first reality check. An electron gun, and yes, an electron gun is a real thing. An electron gun is pointed between Mr. Hames and Mr. Melsna. Mr. Melsna is holding a positively charged magnet, and Mr. Hames is holding a negatively charged end of a magnet. Which is more likely to attract electrons to their magnet? Which is more likely to attract neutrons? Either Mr. Melsna or Mr. Hames. This concludes the first reality check. Section 2 deals with atomic structure and how elements are portrayed in the periodic table of elements. An atom consists of an electron, which is a negatively charged particle, a neutron, which has no charge, and a proton, which has a positive charge. I would encourage you to become very familiar with these terms as they will be discussed in depth in the following section. Down below are two examples of how an element is portrayed in the periodic table of elements. It has an atomic number, an elemental symbol, and a mass in this example. The mass is located here in this example. The atomic number is over here. The symbol is still in the middle. And in this example, it has a charge, which is not included in this example. You may see both examples, so become familiar with both in the future. This concludes this slide. I would now ask that you take out your Chemistry Unit 2 Foundation Worksheet, where we will be dealing with atomic structure from pages 318 through 325. I would encourage you to fill out this worksheet as completely as possible before I go through it. I will now go through the worksheet. The nucleus and the electron cloud are the two components of an atom. In total, atoms are made of 3 subatomic particles. These are the proton, the neutron, and the electron. Down below, we have proton, which has a mass of 1 AMU. Neutrons also have a mass of 1 AMU. Both, as you may recall, are located in the nucleus. Protons, like their name suggests, have a positive charge. Neutrons, once again as the name suggests, are neutral and have no charge. Electrons are a little bit of a special case in that they don't technically have a mass. Their charge is negative, and instead of being located in the nucleus, they are located in the electron cloud surrounding the nucleus. Down below, the atomic number of an atom is simply the number of protons located within that atom. Atomic mass is simply the average number of neutrons and protons added together. There are different types of energy levels in an atom. We will be discussing 3. The inner energy level can only hold 2 atoms. This is the energy level closest to the center of the atom or the nucleus. The second energy level can hold a maximum of 8. This is also the case for the third and outmost shell. I would encourage you to look over Step 1, Step 2, and Step 3 in the atom building procedure. This is an alternative way to discovering both the atomic number, the atomic mass, and the number of protons, neutrons, and electrons within an atom. This brings us to our second reality check. The atomic mass of an unknown element you discovered is 800 atomic mass units. You also discover that there are 319 protons present in your new discovery. Therefore, how many neutrons must be in your element? The second question that is posed: assuming the element is electrically neutral, how many electrons must therefore be present for that atom to be neutral? Please feel free to look over any of your previous notes in answering these questions, or asking Mr. Melsna or Mr. Hames for any assistance in class. This brings us to the final slide and the big ideas in this unit. I would encourage you to know how to identify atomic number, atomic mass, and mass number. You need to know the components of the atom, which are the electron, neutron, and proton. It would be good to know atomic models and scientists' contributions to those models. For example, the Bohr model and the plum pudding model. Please also know how to calculate the number of neutrons, electrons, and protons within a particular element. This concludes this unit.